All right, we're going to do actually the last example on the last page, and then we're going to do a problem from the book that will help you that sets up like 7 other problems. But if you don't watch how we do that and then apply it just a little bit differently to other problems, it won't work for you. But we're going to do the same thing here. It says find this surface area of a regular square based pyramid with the base edge of 10 centimeters and a lateral edge of 13 centimeters. Well, the cool thing is when this works out, we still do our base, and this time we know the base is what? A square. All right, so we have our square. All right, it's 10. Then we also have to find the perimeter of the base because we're looking for surface area, so I have no lateral area for this. I just go 4 times 10, which is 40 centimeters. My area of the base is just base times height, so 10 times 10 is 100 square centimeters. But again, they gave me lateral edge, not slant height. Now what am I going to do? I'm going to again draw the lateral face. Now you only have to do one because they're all the same. And the lateral edge has the fact that's 13. This is 10. But when I draw my slant height in, it bisects this. 5 blank 13. That's right. L equals 12 because of the Pythagorean triple. If not, you use the Pythagorean theorem to solve for it. If you don't recognize, that would be 12. Kind of cool. I love using those. So then when I'm doing the surface area, it's 1/2 the perimeter of the base times the slant height plus the area of the base. So it's 1/2 of 40 times 12 plus 100. So that's 240 plus 100. That's 340 square centimeters. Now, as I'm looking at the example from the homework, we'll work with this. All right, let me find the page here that we're working with. Page 5, yeah. It's going to be on page 540. So page 540, problem number 4. Now this will be applied like for 6 to 7 other problems. Listen to me. If I apply it that many different times, it's going to be on the quiz. And you're going to have to use it, not just to find the slant height, but to plug it into lateral area and surface area. So number 4, the directions say, find the slant height, and if necessary, you round to the nearest whole number. So we're going to find the slant height, and you're given the following pyramid. It has a square-based pyramid, and we're only going to be working with regular ones, so don't worry about if it doesn't look perfect. All right, we get this to be 12 meters, and then we have coming down our actual height. Oops, I just did that one wrong. That should be 60 meters. I looked at a wrong problem. All right, that's 60 meters, excuse me. And when I draw this in, this is 40 meters. Now, we're supposed to be solving for the slant height. That goes right there. Okay, well, how am I going to do that? Well, remember in the very beginning of the notes, the small little triangle down below. The height of the pyramid, the apothem of the base, and the slant height will always make a right triangle. Let me connect this, and then you can see the right triangle. It's right here. Now, what's the apothem of a square base? If you need to see it, I'm going to draw it like this. Here's 60, 60, 60. There would be your apothem. What would its length be? All right, you're right, 30. So that's 30. So now I plug it into Pythagorean theorem to solve for side. Leg squared plus leg squared equals hypotenuse squared. So 30 squared plus 40 squared equals our slant height squared. And if you do this, many of you would recognize, probably without having to do the work, that your slant height is really 50 meters. Now, once you have the slant height, you could go ahead and you could solve for the perimeter of the base, the area of the base, and actually plug it into your lateral area and surface area. So this one, you're going to have to find the slant height, and you use the same type of process for 5 and 6, And then for 7, 8, and 9, you actually solve for the slant height and then you plug it into your lateral area and surface area problems. So I hope this helps you get started on your homework.